Welcome to the third session of the previous event, 3D Technology, a game changer for maritime and shipbuilding. This is the last session of the day, but very interesting session because we have experts from various segments of this industry. We have three industry experts on technology. We have two veterans who are involved with shipbuilding and ship design, and we have people with vast experience in navy and defense. So we have been hearing a lot about technology since morning. Uh, I will limit this session to more on the what can be done in shipbuilding and shipping with this game-changing technology. What are the challenges that we face in adopting this technology to the particular industry? And what opportunities do we see going forward to use the technology for improving the efficiency and the supply chain efficiency of the industry? And also, anything related to certification and training, because whenever the new technology comes into an industry, these are the two things that are primary importance. And any policy requirements that are needed for adopting the technology. So I think this is the should be the scope of this mission, because the organizers were indicating that we should be submitting some recommendations to the government. So anything coming out of these discussions, we can structure them and then present a paper. Going back to today's panelists, I have three sheets of their profiles with so much of accomplishments. If I start reading them, introducing them, I don't think this 1 hour session would be sufficient. So my request to all the participants who are glued to this live session, they are so popular. You just Google their name and then you will find their profiles. So I hope all the panelists would excuse me, but reading out these long profiles, because I want give more dedicated time to the discussions which are important. So with this introduction, I will also not take much of time because moderators love to talk more, robbing the time of the panelists. So the setting is already made. We are looking at the 3D technology, how it can be used in maritime and shipbuilding. Definitely, this is a disrupting technology compared to. I request panelists to keep on mute so that there is no disturbance. They can switch on when they are requested to speak. So, since this is limited to more on a shipbuilding, I have some specific questions. I will kickstart the discussion with these questions, and any of the panelists also, if that question is not relevant to their area as well, but they can pitch in and then chip in and answer those questions. My first question is to both the shipbuilding veterans, Commodore Jitendran. Is shipping or shipbuilding slow in adopting 3D technology? What could be the reasons? Is it because of the sheer size of the vessels, or is it the regulations, or the need for compatible materials?
Well, there are several questions which are embedded in your one question. So I'll try to simplify the answer. You see, the technology is being promoted as if it is a magic solution to to a requirement where if you are having some part that is required or some item, you just put the old one through some funnel and press a button and you'll get the new one from the other side. It's not like that. You see, there is huge amount of design and 3D which goes into shipbuilding. Uh, Even today, in the best shipbuilding nation in the world, it takes 18 to 20 months to design a ship, but takes only 5 to 6 months thereafter to build it. This is because you have to completely 3D visualize the entire ship on a screen and produce the drawings after that from 3D. So visualization, clash checking, ergonomics, piping, how they go inside the ship, how the material will move inside the ship, how men will move inside the ship, everything is put in 3D. In fact, the aircraft carrier, which has been now delivered in Cochin shipyard, the 3D process started early this century, and it was completely done in 3D. So it is not that. So therefore, to achieve that status where we actually started our education with just 2D drawings on using scales, etc., and log tables, and coming to this stage, it is not going to just like that accept something without it helping the existing process which is going on. So you have to first be clear in which area of ship design this technology is going to assist you. I heard two such presentations today in the afternoon, one by Mr. Chaudhary on 3D visualization. Now, I did not find anything new in that because we were doing that thing about 15 years ago in the Navy, and we were doing with mannequins moving inside the ship, how the material will move inside the ship, how 1500 men will move inside the ship from morning till evening, how the pipes etc. will be laid out in the ship without clashing. But he was trying to say that it is something maybe new. I don't know whether it is new, but it is already there. So there is not, it is not will be not considered a game changer as such by the Navy. The other one, which was more interesting, by Mr. Sushil Mane from Altair, he brought out many issues which actually affect shipbuilding. First of all, he said you just like that cannot start manufacturing a 3D printed model until you do a complete study about the configuration of the printer, unless you are very sure about the orientation of the part, unless you are very sure about the support such parts require, unless you're very sure about the material of the model that is to be developed. So, of course, I had many questions. I said, one is to be very clear what is the minimum thickness and maximum thickness at a given point in time that you can use for 3D printing. And the second is what is the achievable limits of additive printing. And also more important, what is the material that cannot be 3D printed at this stage until there is further development in the whole process. So many of these questions will come when you start addressing it to the user, because the user is only going to tell you, look, I have this valve and I want a new one, make as per sample. No, that is not going to, it will be a huge exercise that will have to be done on the material specification, on the reliability, on the 3D visualization and the process and the how it will mate with the existing materials, all those kind of things. So that is why I think there would be not an easy thing into shipbuilding as such, and unless ship design is involved. But in ship repair, where already the ship has been existing for 20 years and we just don't get those parts, then we are not going to be so strict with our concepts. We just want to get on with the thing, so we may be a little more conducive with what is available with the latest technology and accept such parts made. There also the questions will be what materials cannot be used and what can be used, etc., will come into play. Otherwise, as a concept, It has got potential, phenomenal potential in shipbuilding, ship design, ship repair, offshore engineering, submarine design, submarine building, including the hull buildup of submarines, dredging industry. And something which came to my mind when I was thinking, I spent 8 months in the shipyard just to make a layout of the shipyard. It was so difficult, 250 acres. We could not make a layout because I wanted to introduce 5 or 6 new cranes in such a way that economically every inch of the shipyard is coming under a crane. I am very sure every port has the same problem. Material movement inside a shipyard and inside a port is a huge issue by itself, costing a lot of money. So, making models of ports and shipyards for material movement is another area which definitely this technology can help. So, this is
Comrade
what is.
Jitendran, I'll come back to you again.
Yeah, fine.
Yeah. Do we have Naresh Kumar ji on the panel? Yeah. Sir, would you like to add quickly? Yeah.
Absolutely.
Naresh Kumar ji.
Now, as Commodore Jitendran has pointed out, shipbuilding design and construction in the shipyard is a different exercise where a lot of 3D software like CATIA, Ship Constructor, PLM, these softwares are internationally known and being used in design of the ship. That is, ship is a large, you will have, aircraft carrier will have 1 ton panels, each weighing some 10 tons, 100 tons, and so on and so forth. So those panels, for example, major part of the ship construction is building the hull itself. So building hull is a very, very massive, heavy industry exercise. This is not susceptible to 3D printing, definitely, because making a panel of 100 tons by welder and by conventional manufacturing techniques, plate bending, etc., will be much faster than 3D printing, definitely. Because you have to deposit so much of steel there, it's not possible. But certain parts of the ship, for example, the bulbos or forward portion of the submarine, which is a very, very sophisticated shape, that part being small or smaller in shape can possibly be attempted in 3D, and that is what I think some of the examples were shown. For example, propellers. Now, propellers, thousands of them are used in merchant navy and so on and so forth, and boats and crafts and so many other. Volume is so high. So, if you want to manufacture propellers, it's a very complex shape, like a turbine blade, and difficult to machine by conventional machining, and therefore susceptible to 3D printing. Like that, so many brackets and some odd shapes, like fins and so on and so forth. Those parts already, from the presentation, it appears that so many of them are being done in the shipbuilding industry also. As far as the repairs is concerned, as we said in the morning, now naval dockyards, each dockyard has got some 100 centers, work centers. They do a specific job in a particular area. For example, somebody repairs hull, somebody does dry docking, somebody repairs engine, somebody does electronics repair, somebody does. So many things are there in the ship. It's not one particular thing. So mostly what has been tried in the naval dockyard, as you could see even from the presentation, somebody has said that we are working with the Navy in the naval dockyard, and naval dockyard has set up a center that has been primarily to re-engineer some of the mechanical parts. Most of them, either impellers or some fittings or some for which the spares were not available. In the morning also I quoted an example, the Russell submarine. Hundreds of them are used, but they are not available. So those were being manufactured by conventional method can very easily be manufactured by 3D printing. So I feel that 3D printing center need to be set up in both the naval dockyards or wherever naval repair centers are there, and which I'm sure Navy has already started doing it. In case it is not, formalized, the industry, as I have seen in India, so many companies are doing 3D printing. They are making the machines. They have the know-how. They are also doing the production, including L&T and many others. Navy should set up a center for 3D printing in naval dockyard, primarily for repairs. so that, all these industries, we have something called waterfront facilities where the industry can come into naval dockyard, set up their center and do the repairs or service whatever is needed. So that will be very good initiative so that, industry come to know what is the requirement of the Navy and they are able to provide a solution there on the site. As to production scenario.
Thank you, Commodore Naresh Kumar.
Thank you.
My next question is to the three industry experts, Ashok Vermaji, Daniel Tan, and Vishwas Putige. Sir, you have heard from the shipbuilders the challenges that they have in adopting to this technology. So, as a solution provider, can you give me some an insight into what is the status? I believe Daniel Tan can tell me that I think Wilhelmsen has made some inroads into this 3D printing in shipping industry. So, what actually are the challenges, and what is the intent from the industry that you see, and how can we motivate the industry to adopt this technology? In any order, three of you can answer quickly, please.
Yeah, maybe I can start with small comment. So one of the things that we thought, one solution that we thought can really move us, our end users, to adopting the technology better, is in scanning solutions. So we have been trying very hard to find an appropriate scanning solution that can be used, let's say, on board a vessel, where a layperson can operate it. It's relatively inexpensive, so even if you lose it, you damage it, it's okay. And it's going to be split across like 3,500 vessels. Yeah, so we need a cost-effective solution. So having this scanning technology would really help us in getting the requirements for the part. Currently, it's as shared in my presentation, it's all hand-drawn with manual measurements. If we can do a 3D scanner with a high enough fidelity that is cost effective, it will help in a lot the quick capture of the part requirements, and then they can send us a digital file, we can fabricate it. For vessels going alongside ports, there's no issue because they do it from time to time. The most important part is to capture all the design requirements.
Thank you.
Ramprasad, one very important problem which has been coming to my mind, which I must project to the industry today, is the submarine hull survey, for example. For a major repair of a submarine, the hull survey requires removal of all the equipment and survey each and every compartment for pitting and corrosion. This takes almost 1 year to 2 years. So by using this new technology of scanning, after the equipment has been removed, is it possible to do survey of the submarine hull? Because the compartments are so small and you have to go inside and then man has to sit there, he has to measure with each vernier the amount of corrosion, etc. and then come out with a build-up solution. So if some robotic tools can be made use of to survey the submarine hull and do the building up of the submarine hull, it will be a great time saver, at least for 1 year in the submarine repair time.
This is not 3D printing though. This is a totally different game. But anyways, good question.
Yeah. Request Ashok Vermaji and Vishwas.
Vishwas, you go first. You're the young one. You're my protege.
Sure. Yeah, sure, right. Okay, so from a preparedness perspective, to answer your question, what one needs to do from an industry perspective, I think first and foremost, industry has to work more closely with the shipbuilding teams, which probably I see there's a gap in understanding the requirement itself, which probably has been missing out all these years. And now that there are platforms like this, where we do have this matching that's going on, where people are able to understand the requirement much better, and also bringing an awareness of what the technology can do I think is a great start. So kudos to the organizers that something like this is being created. And of course, there's no one size fits all from a technology perspective as to what would be suitable or one technology that would be suitable. Of course, like it has been pointed out, there are multiple technologies from metal printing itself for both repair, MRO, and for creating new parts. So for a lot of the larger parts, as we've heard and seen, the DED kind of technology, the hybrid kind of technology is much more productive, much more useful in terms of delivering the results faster and productively. So that is something that can be explored. And there are today, fortunately, there are manufacturers sitting here in India and coming up in India who have the expertise or ability to demonstrate capability and do things and partner together. And of course, from a smaller parts perspective, there are other technologies like the powder bed fusion, the binder jetting, and others which are coming up again in India and which are available. And that's something which is a little more well established in terms of applications and deliverables that has been happening. So I think starting off from platforms like this, if there's a much closer interaction of understanding and capability between the industry and the two sides from the shipbuilding, then I think a lot of the gaps can be bridged. So that I think is the first initiative that we should do in my little opinion, and where like our respected gentleman spoke earlier, from the very beginning, from the design stage itself, we'll have to start exploring what aspects will have to be considered to keep the manufacturability in mind when we go ahead and do the design, and see how we can adapt to some of the advantages of 3D printing and include that in the design stage, at the design stage itself. So this I see or feel is the necessity, and today India has come far in terms of understanding the technology and making it available for both design, manufacturing, and finally execution of the whole project. So together we can make this a good, successful initiative for shipbuilding also. So I think the shortcomings have been there, but a lot of things can be bridged very quickly and move forward. So that's my little view.
Thank you, Dr. Vishwas.
Thanks, Vishwas.
Usha Kurma ji?
So I'm on stage now?
Yes.
Okay. I'll try to keep it to less than 2 minutes. First of all, shipbuilding, marine, maritime, in my experience worldwide and certainly in India, unfortunately, is not a priority for any government. It isn't. That is a shame, but it isn't. Now, extending on that, Navy, naval warfare, submarines, battleships, aircraft carriers, they're everybody's priority. So that is the way life is. Okay, having said that, 3D printing and additive manufacturing for marine and maritime, as my presentation was very, very clear on, it's not really for making parts. Plastic and polymer parts, waste of time, bullshit. Small metal parts, waste of time, some value, but really not useful. Big parts are very hard to make. Very expensive machines. I deal with $4 and $5 million cost machines, and I know that India will never buy it. I've tried it for 10 years, so India is not going to buy it. And I have dealt with the Minister of DHI and Defense Minister, even PMO prior to Modi ji. Koi nahi kharidega. So that is a waste of my time. But repairing and repurposing equipment of marine and maritime to get off the dry docks into ship really fast, into sea really fast, or repair certain things right on ship. No, that is a game changer. It is a game changer. And that's also what I said in my presentation, that kuch to karna hai. Because you have thousands of ships floating around with hundreds of thousands of problems of mechanical, wear, corrosion, this, that, whatnot. Kuch to karna hai. That is where 3D printing, especially directed energy deposition, and not because I'm a proponent of DED, which I am, but I'm saying it as an industry advantage. DED is the primary solution for marine and maritime. और क्या कहना है? India needs to invest. Indian government needs to invest. I mean, I will give you two numbers. The total investment by foreign governments, including US, European Union, and Southeast Asia in 3D printing since 2008 has been about $5 billion, and Indian government in total, that includes defense and aerospace and academia and whatnot, MSME, total investment is less than $20 million. You figure it out, because that is where the equation is unbalanced, and that is where the equation has to change. That's all I have to say.
Thank you, Ashok ji, for very straightforward and candid remarks. Hope someone in government listens to this. Before I bring in Dr. Kandukuri Sastry, I would like to reach out to both the experts from Naval, Commodore Niranjan and Commodore Anil Jai Singh. Sir, we have heard that in shipbuilding, Jitendran has said that it's a very complex and difficult processes. But Naresh Kumarji suggested that Navy should have a 3D printing center, and even Ashok Vermaji also said commercial shipbuilding is not a priority in India, but naval is a priority. So you are in the line. So what is your perception, Navy perception on using 3D printing for naval vessels? Please.
Should I go first? Commodore A.J. Singh here. I think, firstly, just naval shipbuilding by itself is not an industry. Shipbuilding has to be a national effort. And it has been identified by the government now as I know it's not a priority sector in the real sense of the term, but priority is being given to it in the new maritime vision, because it's a strategic asset to have a good indigenous shipbuilding industry and your own indigenous shipping fleet, merchant shipping fleet with tankers. That is one. Secondly, as far as the Navy goes, yes, naval shipbuilding is pretty robust in India. It's a robust program. And I think this is one place where we definitely need to improve our efficiencies. You know, we take almost 7 years to build a destroyer. China built a destroyer in less than 3 years. So and we have limited number of shipyards in the country. So if we have to develop capacity, obviously shipyards can't come up in a day. We need to expand our Navy. So notwithstanding the budgetary issues which may be there, even if you give any amount of money to the Navy, there is no capacity to build more ships. There are already shipyards already full, the government shipyards. So I think we need to create more efficiencies, and 3D is one way of doing it. But more importantly, as far as the Navy and the Coast Guards are concerned, I think it is the ship repair capability, the dockyards, and onboard 3D repair, which is very significant. Ships can be turned around much faster in dry docks. You know, the Navy's got a very large role to play. We are putting 15 ships on multi-mission deployments all over the Indo-Pacific. To keep those ships going, you need to have quick turnaround time in dockyards for refits. And that is very important. The third thing which I just want to bring out is that, and of course, these ships which are on deployment, they need logistic support. Now, let's say a ship is operating in the South China Sea. It can't afford to get the kind of logistic support for small little parts which may be required. So, in fact, if you ask me, every Indian naval ship which is deployed must have a 3D printer on board for the basic spares that can be fabricated on board.
More than one.
Many years ago, I met a US Navy admiral, that was I think 2015 or 16, at a conference. And at that time, they were planning to equip every big US naval warship with a 3D printer of its own. I don't know whether they've done it or not. And that was my question to Daniel about, is the Singapore Navy doing something similar? Because they're a very progressive Navy in their thought process. The third thing is, the 3D industry in India is still largely an MSME-oriented industry. You don't have big industry doing 3D. And MSMEs in India, despite everybody saying that, they are the fountainhead of innovation and all technology comes from there, have not got the kind of traction they should be getting in the country. Defense MSMEs are treated separately. The regular MSMEs are different. So I think to get that voice to be heard, either the 3D industry has to come together through the industry associations and have their own committee or subcommittee in the industry associations to bring that voice to government, because small companies do not have the bandwidth to come and canvass or put forward their case in Delhi and wait interminably for some bureaucrat to meet them and look favorably at them. So you have to have a collective voice, and this collective voice must also ensure that it becomes very integral to the entire shipbuilding and ship repair industry in terms of as tier 1 and tier 2 suppliers. That is another important aspect, I think, which the 3D industry in India, particularly those in the maritime domain, must look at. The country has, this government has brought in a couple of very important initiatives. One, of course, is Sagarmala. Now, Sagarmala is a multi-trillion crore project over 20 years. And that is all about port-led infrastructure development of the maritime sector in India. So it includes shipbuilding, it includes ship repair, it includes ports, and very importantly, which was never considered in India, was inland water transportation. So they're developing a whole network in the country for inland water transportation. So I think the fishing, now they're trying to modernize the fishery industry in India. Instead of traditional fishermen going in small boats, they're trying to bring in improved training. They're wanting to set up centers of excellence in ship design. So across the spectrum, there is a lot which could be happening in the sector, or which the government at least has got a roadmap for doing. How much they actually achieve will depend on how good the implementation is. But I think into this architecture, 3D technologies and across the entire maritime sector need to be introduced and brought to the notice of the policy makers to improve efficiency, because that is the fundamental requirement.
Yep.
I won't take much more time with this. I think that's all I really wanted to say.
Thank you very much, Commodore Ranil Jail Singh ji. Now,
I'd like to add
Commodore
I'd like to add my perspective to this.
Yes.
Ship design and ship construction in Indian Navy and in our shipyard has been at the forefront of induction of EA and VR technologies for designing of ships. And I think from the time we have taken up, they have matured, and the designs that we see are testimony of our resolve that Indian Navy, together with the shipyards, have done so well in reducing the timelines for finalizing of the design and for making it ergonomically efficient. And we have used them for improvisation of the operating envelope, so that the ship's crew are able to utilize them properly. And digital shipbuilding is like crystal ball with many technologies maturing, and future is bright for us. And these initiatives have reaped rich dividends for platform management during construction and production planning. The Navy and the shipyards have also begun an exercise for utilizing for mapping of equipments during the process. One of the firms was mentioning about assembly verification that has been widely used at the shipyard. But at Naval Dockyard, definitely there is a scope for using them during the medium refits and during the midlife updates, and also during installation of new systems and where the old obsolete items are removed. Probably this technology by Ferro can be utilized. As regards the rapid manufacturing, there have been some small centers in Dockyard Bombay as well as NSRY Kochi for manufacturing some components, although some components have been made during the COVID time, but a lot needs to be done as there is a lack of drawing, and the time required to manufacture these are critical, so the requirement doesn't exist by the time the requirement is somehow met. Yes, for some gas turbines, spare parts and turbochargers and compressors for impellers and some titanium valves, various dockyards have outsourced it to various manufacturers in India.
and there has been some headway. Also, I was telling in the morning that Navy has placed an order for a 3D manufacturing lab to be set up in one of the tankers, and probably in next 1.5 year it will be set up in one of the tankers. And futuristic aircraft carriers definitely may have one, as envisaged by our senior veterans. And some takeaways from today's seminar, which I would like to dwell upon, is definitely we need to have a national cluster for additive manufacturing in a central place where the users could throw up their challenges. Because although we have some small centers, but definitely it not be cost effective for us to maintain them and to make it regularly and repeatedly. But however, definitely these help of these national cluster, if they are there, they would be definitely be full for the naval dockyard and for the shipyards. Other areas where I can think that we can have a utility of this rapid manufacturing are the jigs and fixtures, test stands and tools for major overhauls, because these are quite expensive, and however, if they are manufactured indigenously, the cost would definitely be lesser, and also it will save foreign exchange and also generate employment. So I think the proposal given by Intech for manufacture of jigs and there is another area for ship owners and ship operators who operate the ships at various west coast and east coast, as well as in the Andaman Islands. Definitely, we can have some containerized manufacturing facilities at remote locations, so that any defect is attended immediately at beck and call at remote locations and facilities. Similarly, for some other ship owners in the maritime domain, it may make sense to have a few of these containerized facilities at major ports in Southeast Asian region or from the region where they're operating. Scanning technology, which was mentioned, is definitely useful because it affords us a 3D drawing of the item which is required to be manufactured. So 3D scanning has not come in a big way, but definitely the Indian Navy can look in whether they would like to do it themselves or they would like to outsource it, rather than have the trained manpower for this, rather than doing it themselves. Probably outsourcing would be a better model. And another thing which was mentioned about the scanning is as fitted drawing, as build state of equipment and machinery, the repository of the shipyards who make the ship fit document, or SFD, what we call it, that the scanning technology would definitely be utilized for making a good ship fit document, which ultimately is handed over to the Indian Naval Ships Maintenance Authority, and this will be for some use. Another thing is that almost the inventory carrying cost by the Navy is almost about 15%, which is quite large, and we hold almost about 5.5 lakh inventory in our material depots, out of which 1.5 lakh plus is a fast moving inventory. But a lot of dead inventory is lying there for years and ages. And overall, if we see for the last 50 years, we keep this inventory for as a war stock or a reserve stock. And however, we have seen that not even 20 or 30% is utilized, and almost 70% goes waste. So this is one area where we can reduce our inventory carrying cost or the project cost when initially when we when we get into a contract. This amount of money can be saved. Rather, we could invest in getting the drawings of the shafts or propellers are made, and all the critical, which will only be utilized once in 5 years or 10 years, or only in case of emergency. We need not buy them. But as part of the project, we end up buying 10, 10, 20, 20 propellers, 15, 15, 20 shafts for a set of ship of a project or a class. And these, I feel, is a wasteful expenditure which can be avoided by rapid prototyping. But however, in case of emergencies, we need to have the 3D drawings available so that they can be made. And we can reduce the inventory carrying cost for the Navy. And similarly, it also goes with a lot of OEMs. OEMs can also reduce their inventory carrying cost, provided they have the 3D drawings of these components.
Thank you, Commodore Niranjan.
So
Sir, we are
these are
running
the
out of
areas
time.
I think the industry can look in, so that we can reap rich dividends from this technology. Thank you.
Thank you. Thank
निरंजन
you.
सर, आप दिल्ली में हो?
I'm in Mumbai.
मुंबई में हो आप? ओके, ठीक.
Just a reminder that we have only 8 minutes left for the session. Unfortunately, I can't do much about that. Sorry, Dr. Shastriji, Kundukuri, I have kept you waiting. You are having a deadly combination that you are sitting in Norway and you are with DNV. So, can you give me some insights into what kind of certification or accreditation that these 3D printed parts get when you use 3D printing for these parts in shipbuilding and being a classification society? Can you give us some insights into that? And India being at the very threshold of this using this technology, if you have any suggestions so that I mean India can take advantage of it while moving forward, learning from this. Over to Shastri.
Yeah, thank you so much. I'll be quick. Let me see if I'm yeah. Regarding your question about how DNV's certification and classification, yeah. I mentioned in my presentation, lot of people have an upward or bottom up or upside down thinking. For example, when 3D printing came, when you can make small parts or a low critical parts and test it, many questions were coming from around the world. Hey, can you make a very very critical part like an engine part or something a very very critical structural part? So there was a lot of discussion around the world. Unfortunately, a lot of companies have started, and both you have seen that printing gaskets to all small critical parts to core like connecting rods are very critical engine parts also made, turbochargers, etc. So DNV was seen as a go-to company organization to tell that because of the certification hurdles we could not actually unlock the potential of AM. So that's why we got deployed all our efforts, and actually we have accelerated and made a series of standards. And the primary question is, for the new building, you always are for traditional manufacturing. You produce thousands of parts, in one go. Means one part is produced thousands of times. So traditional manufacturing is very very effective in that sense. But when you have to use it as a spare part, you are actually producing one time thousands of parts. So traditional manufacturing, your other minimum order is like buy 100 parts or no part. That is where the gap. So all our rules were made for the new building. Spares were always made, stored, and distributed. So somebody is making 100 parts, somebody is storing in 10 places and distributed. So now we have made rules and certification that how this can be profitable and how still it work. The certification, because the traditional way of certification the costs for certification can be easily taken by the large volume. So the main hurdle was if a part is made by $2,000, but certification or qualification could cost even $20,000. That was the situation once. So our goal was to bring it almost 20% of the cost or 10% of the cost for very critical parts, the certification. It was very ambitious. we are able to make it. So I won't go much into so many details. We have so many solutions given that, and we will be happy to help people. One important thing that how I can suggest. I've been meeting the heads of world leading shipyards and hundreds of ship owners around the world. So why people are coming to us and talking on 3D printing, it is not just because they can replace one part here or one part there. In that sense, that is not a way to, it should not be elevated as an important technology. Then it is one of those sideline technologies. But why people are talking to is, when you see the 3D printing, you can see it as a part to part replacement, or you see it as a solution, or you see it as a service. So, for example, like lot of people talk to me. I forgot. I think so. One is called F360 or F300. One of the most science fiction type of a ship that somebody, I think so, Italian owners are going to build. They met me several months ago, and you can see that when there is an innovation that actually have a zero carbon neutral and electricity neutral and energy neutral, so many features. If people wanted to produce such innovation concepts, they use 3D printing. People are preparing for warlike situation. If I have to make so many things so fast, I should have a capability how 3D printing can help me. And if I have restrictions, or sanctions, I was there in India in 1980, 1998, 99. I was helping ISRO. I have developed a marine steel component material for our rockets, together with DMRL and together with IIT professors. So I know that how it is like, when sanctions are there. So India need to prepare for this. So again, I repeat, for situations like innovation, situations like warlike, situations like sanctions. So 3D printing capabilities to be developed in that sense. You need to have an objective. Many countries are doing import substitution, and many countries are making for as an export value. That is like Singapore wanted to have an export value. And of course, one important thing is inventory control. Thousands of millions of parts are spread everywhere and become useless over time. So we are working with tens of companies about making this digital inventory guidelines, and how this still we can do certification with a lightning fast. Normal traditional certification could cost need several months, but can we match the regulation approvals with the lightning fast? And also, the important thing I would say, like what the recommendations I gave to Singapore government, they took for created national roadmap. They already have a national cluster that India could make, and provide financial and regulatory incentives to encourage adoption, uh, give tax breaks to those ship owners and shipyards that use 3D printing. Once you create the demand, automatically the capability will come and suppliers will come. So I'll stop here. But one final thing is what I saw the world is the ship owners that are ordering whether it is a submarines or is it new ships. They're ordering that 10%, 20% of the spares must be supplied with the in future by the 3D printing. This is actually putting the suppliers into pressure, and they are now turning. So yeah, all these things can be done. Thank you.
Thank you very much, Dr. Sastry. You have given us a long list of to-do things, and yeah, we need to really work. And each issue is so big and complex in Indian context and framework. We need to spend a lot of time consulting with the government and other agencies, associations, bring them on board. I have been hearing a lot of applause during your talk. I don't know that organizers wanted to create that kind of ambience to create that mood. Anyway, congratulations for that. In fact, I have a few more questions, but as I said, the time is a constraint, and the organizers have ambitiously put together several experts in one panel. As Vishwas was saying earlier, to create more awareness, to create more dialogue, we need to have these kind of sessions, a day-long sessions, in fact, on each of the issues to discuss threadbare and then actually put qualitative recommendations together. So even if I extend the session by 10 minutes, it's not going to help us. So what I am going to do is I'm not getting into the details of whatever we have already discussed, but there are a lot of valid points have come up. We need to have more awareness, sensitizing the shipbuilding industry and ship owners on the use of 3D technology. Repairing is one major area that low-hanging fruit that we can immediately focus and then start understanding what we can do there. Then we should have a national cluster for additive manufacturing. Maybe we should look at a 3D printing center for naval because the CMD, ex-CMD also mentioned, and even naval officers also mentioned about this, having the center. So all these recommendations and what we do is under the supervision of Wing Commander Raman Sopre, we will sit together and prepare recommendations. And as Dr. Shibu mentioned, we will also use our magazine as a platform to start publishing some of the articles on how 3D printing technology can be enabled in shipbuilding industry. So with these remarks, I request Wing Commander Raman Sopori to give his concluding remarks as session chairman. Over to you, sir.
Thank you, sir. Thank you all the speakers since morning, particularly our friend from Norway who has been up since morning and friend from Singapore. Must be dinner time for him. I would not like to add what has been discussed. My role would be to connect the dots. I generally am optimistic and seeing the glass always half full. But looking into the policy of the government, I am today sad to say the glass is half empty, particularly because as I saw the government of India's policy, which is listed on the Ministry of Electronics website, which issued in December, about a year back, I have to read just one paragraph on this because people are discussing and talking about different market size of the global market, what is India's share, while we are discussing the shipping industry and naval industry today, but we will look at the large picture. I am reading out the paragraph from Ministry of Electronics white paper, which is a 67-page document, and it is talking of the global spending on printing technology, 3D printing, in 2019 was about $14 billion with a growth of about 24% per annum and expected to reach US dollars 34 billion by 2024. That is growing at CAGR of 24%. Then it talks of various areas of this thing, and then it talks of the US market is about 36%, Asia is about 28%, European Union is about 26%, and other countries is 10%. But let me talk of what is India's share out of the Asian percentage of 28%. Out of the Asian market size of 28%, China is 47%, followed with Japan 30% market share, South Korea 10%, ASEAN countries 5 to 7%, Australia 3 to 5%, and India is right at the bottom of 3 to 5%. That's a very pessimistic scenario. Now, unfortunately, the entire Ministry of Electronics National Strategy for Additive Manufacturing does not have even a single paragraph of shipping industry at all. So the challenge for all of us stakeholders is, while the government has come out with Make in India policy or Atmanirbhar Bharat, make in India for make for the world, we have to now educate the policymakers to add a white paper to the government. So while we'll do a draft, we'll circulate the draft to various things. Unless we add the larger picture, the naval requirements, the shipping industry will not see the light of the day. We have to see the certification. Mind you, money will not be a problem. So we are now getting into the election mode also, and the budget of union budget is due about a month from now. We have to put our acts together, and there are some challenges on education industry also, as Mr. Ashok was saying, that India has not spent enough money because the shipping industry per se does not even get a paragraph in the national policy at all. So I can circulate this document to our website also. I would request you that please put your hands together to Dr. Shibu John for an excellent show, but we have to cover quite a lot of milestone. While the naval requirements, the shipping requirements are there, but that's a very small market. We have to look at the global market per se. The best practices, we are the best thinkers in the panel today. Each one of you has got experience. So we have to work out to-do list out of, let's say, 20 items. What are the 10 things government must do by way of boosting the investment in this sector? And then what are the key takeaway points? With this, I close and hand over to the session chair and Dr. Shibu John.
Thank you, sir. I request Dr. Shibu to come over and then conclude the session as well as the conference. I think this being the last conference.
Yes. Thank you so much, gentlemen, and also the session chair, Wing Commander Raman Supuriji, and also our key respondent for this panel, Mr. Ram Prasad Ravi, who is the managing director for Maritime Gateway. So we would also want to work with you, sir, because you also have been leading the front in the maritime and the shipping industry in terms of also sharing the recommendation that we will actually be able to get from this particular forum to also be to share this with DG Shipping, and also through Ramanji. I think the committee that we have actually to constitute will also have a greater role to play, because I think there has to be also what I believe is a national additive manufacturing innovation center should be the leading space, leading way for us to look at.
There are some centers already there in different parts of India, government of Gujarat. In fact, just for the sake of gentlemen from Intech, that is one company which is listed in the national policy as a mark of recognition. But many things are not happening. It's only import and sell. So we have to now educate the people who are making the policy itself. Over to you again, John.
Yeah. Thank you, sir. Thank you so much for that insights also. Yeah, I think it is a concreted effort for us to all work together. Shipping and maritime, somewhere I did have an opportunity to work with Mr. Ram Prasad in my earlier times, and that is where I could connect with him. And I understand it has always been kept at bay, maritime and shipping, but has a great potential. Now that we talk about 7,500, the coastal space that we are actually in, I see countries like Singapore, like a maritime nation. Why can't India look at that kind of a scope? But I think lots are being done and it has been taken care. And also, we also spoke about design thinking. If design for additive manufacturing can be also looked at as a one part of a course or a curriculum in these institutes, I'm sure there's a great opportunity going forward, because I think the students and the aspirants needs to know about this technology and see and think, reverse, to design and create products which can be more effectively in terms of saving cost, efficiency, speed, and lighter. So I think thinking back in the reverse form is what the digital, design for additive manufacturing is also has a great prospect. While CAD designing is a regular term for the subsequent technologies that we are already using to machining. So I think there's a great prospect for all of us to come together, work together as one, in confluence together. And I really thank each and every speaker and panel members who have contributed their active participation, sir. Thank you so much each of them for being a part of this, and they're also officially our 3D Graphy engineering advisories. So it will be great to work with all of you to see that how maritime and shipbuilding from your area of expertise can come to the terms of how this technology can be adopted. Thank you once again for your active participation, sir. And may I leave it to the Mr. Ramprasad ji to maybe make the final conclusion, and then we will conclude. Thank you so much, sir.
Thank you, Dr. Shibu. I don't think there is anything to be added because a lot has been spoken on what needs to be done.
Yes.
All we need to do is pick up our things and then start working on whatever has been discussed. Because in a day's conference, the number of ideas, the thoughts, and the suggestions came in. If you list down, I think we have more than a year's work at hand. So let us walk the talk and let us put the discussion to the rest and look forward to see all of you collaborating and then moving forward. Thank you very much. Thank you, gentlemen.
Sir, I have got a small suggestion as a feedback. Dr.
Please,
Shibu
sir.
and Mr. Ramprasad.
Please, sir. Please.
See, while we are all busy today, we'll close down and you can have a drink in my name. We need to have a small 30-minute follow-up session on our, if we can get that thing together, so that before we submit our recommendation to the government, if people can submit their suggestions, just bullet points with some facts and figures, what needs to be done. I'll circulate the national policy document of 67 pages to all the panel members here. Please insert a paragraph what needs to be done, and I'll be more than happy to push that to the PMO straight away, and from PMO it goes to Invest India and to Ministry of Finance. Rest of the things will follow. All other ministries will follow, because unless you make some noise, nobody will listen. The dockyards and all things will come only when the Government of India, Minister of Defence pushes them down the throat. So what I would request is, we would like to have a session after maybe 2 weeks with all your recommendations. Earlier the better. Don't have to wait for 2 weeks. Anybody having a suggestion, I'll request Shibu to create a small WhatsApp group so that we can move faster. And anybody having a document and all, it is not to sell a company's portfolio. It is to work for India and India's policy to boost business comes to. We have to put all the stakeholders, particularly people who are in the different time zones from Singapore to Norway, and to US. Thank you so much for taking the efforts of killing your breakfast time and dinner time. So I would like to have this group done. Thank you so much.
Thank you. Thank you so much, sir. Thank you so much. Thank you.
Thank you very much, sir. That's a very good suggestion. We look forward to interact again.
Thank you, sir.
So with this, Shibu, I think you can close the session.
Yeah.
Exit the room.
Yes. Thank you so much, sir. Thank you, everybody, for this wonderful presence. Thank you, sir.
Shibu, I wanted to say something about. Are you able to hear me, Shibu?
Yes, I can hear you, sir.
Yeah. So I think it's an excellent idea. I think so. You need to create a lobby group or a think tank group. I think sort of think tank here. If you make then get formally recognition to this, because you need neutral bodies like this, and that should advise. Otherwise, everybody is pulling and pushing. And if you form that and show that to the government that this is the place to go, or it's an independent verification group, then it would be nice that you could follow so many things. Yeah. Okay. Thank you.
Right. And I think as an example has already been set by in Singapore government also. The NAMIC is a good initiative. I think so I think fantastic, sir. Thank you so much. Definitely we'll work towards it.
Thank you.
Thank you. Bye.
And we will also need inputs coming from you in a short note, because we will also be making a formal coverage in Maritime Gateway as one of the magazines. So that will also be that we are connecting with many stakeholders of their interest in a technology that is very futuristic, to see that that can also be activated. Thank you so much, gentlemen. Thank you, Daniel. Thank you, Commodore Jitendran. Thank you, Commodore Arun Singh. And thank you, Commodore Nirijan sir, and also Dr. Shastri. Thank you so much. And also Dr. Vishwas.